911, what is your emergency?
Hi, I'm Haasini, the EMT that would be responsible for the situation, but I feel uninformed and underprepared. I don't know about the traffic conditions, weather patterns, or other environmental factors that would impact my way getting to Sreeja. And additionally, I have no direct way to contact the hospitals that are responsible for continued patient care.
So, introducing Apollo, which is an EMS optimization. So we have the problem of EMS wait times continuing to be 3 times higher in rural areas of the state compared to urban areas. For every minute that it takes longer for her to reach the hospital is another 7 to 10% loss in lives, and less than half of the EMS records are correlated perfectly with the hospital trauma records. Um, every second matters.
Right. So in developing our solution, we harnessed many different open data sets from the New York State website. So we were looking at traffic congestion, 911 end-to-end response times, dispatcher data, inequity, and social factors to look at how these various factors impact EMS's ability to get to various locations and conditions. So our solution streamlines the data to provide accurate information so that ambulances can pre-position. Essentially, this means instead of starting at their garages, they can position themselves at other locations to have greater availability and lower their response times, as well as establish direct communication to hospitals. So they can actually communicate with the doctors and nurses that are going to be continuing patient care.
Okay. So we got a heat map here. We pulled from publicly available New York City EMS data that shows certain neighborhoods that are at risk, Inwood, Helm Bay Park, JFK, or beaches like Breezy Point, that experience high emergency incidents, longer EMS response times, and it contributes to higher mortality rates. By strategically increasing the EMS hubs we plan in these underserved areas, we can reduce response time and save more lives. Um, these are some of the areas. So Inwood has only a few highways going through it. It's hard to get in and out. Um, this is a beach, as you can probably understand, is hard to get in and out of. Pelham Bay Park, um, as well as JFK, which is a very odd position if you need emergency care. Um, and if we pre-position these ambulance or EMS places closer to emergency care, we can increase survivability. Sorry. As you can see, the second main facet of our app Apollo with this wireframe is paramedics can speak naturally during transport, while a real-time AI-powered platform captures and transcribes the handoff seamlessly in the background. The system extracts high-priority clinical data, generates a decision-ready summary, and pushes it to a live emergency room command dashboard, so the right team can be mobilized early and care can begin with greater speed, coordination, and situational awareness than ever seen before.
So we just have a quick demo right now. Um, on our website here, basically you can kind of simulate certain traffic conditions. You can look at the weather, you can look at Medicaid access, the time of the day, population density, and then one of the things that we also included here was health outcome rates by the historical neighborhood grid. So that talks about socioeconomic factors, which is something that Google Maps doesn't really consider when you're routing an ambulance. So this is kind of just what our website looks like. And then here we go. So with this, you can kind of tweak out certain factors of where you might want to place your ambulance, and then you'll get what the response time looks like. So you can see that you can shave off a couple minutes through changing around your settings and positioning ambulances accordingly. And as we know from earlier, a couple minutes is many lives.
Okay, so first we created our idea, and then we utilized Cursor and Claude to help us search for available datasets and identify desired outputs.
So in the future, we think that this could be really valuable for revolutionizing how EMS systems and hospital systems work. And we think in the future we could provide direct routes so that these services and providers are able to find the most optimal route with all these factors that are considered. And we can use further data from the New York State datas to update these informations. And we could also allow for live chatting because right now what we have is transcription. So when EMS providers are in the ambulance, they can, you know, transcribe particular things and that transcription can be sent directly to providers, but we could have live chatting or telehealth to make that transition even more seamless.